In this video, we're going to take a look at yet another type of indeterminate form. In this example here, we can see that if we plug 1 into this function, we get infinity minus infinity, which again is another indeterminate form. Infinity minus infinity might still be infinity, or it might be some other real number. It's indeterminate. So once again, we're going to do a little bit of algebra and rewrite this so that it is in a L'Hopital applicable form. In this example, we notice that we are taking a difference of two fractions. So the immediate technique is to combine your fractions and see what happens. So we'll give that a try. So combining our fractions with a common denominator, we get the following expression. I strongly encourage you at this point to pause the video and work out this algebra yourselves. Make sure that you do get this same expression here. At this point, if we evaluate this limit at 1, we can see that we get a 0 in the denominator, and we also get a 0 in the numerator. So this is in L'Hopital form, 0 over 0. Which means that we can proceed by applying L'Hopital's rule. Notice in the numerator, we will need to apply the product rule for this piece, giving us ln x plus 1. And differentiating the minus x gives us just a minus 1. In the denominator, we will also need to apply the product rule for this piece. At this point, we will try to simplify this fraction. Here in the denominator, we have just combined our fractions and then move that extra factor of x to the numerator. If we attempt to plug 1 into this, we get in the numerator a 0, and in the denominator another 0. Since this is still in indeterminate form of 0 over 0, we will apply L'Hopital's rule once again. This involves us taking the product rule on x ln x once in the numerator and again in the denominator. What we are left with now is a much nicer limit, because if we plug 1 in now, the ln x's go to 0, but the 1 and the 2 in the numerator and denominator respectively leave us with a real number value, 1/2 in this case. Similar to our earlier example, we needed to apply L'Hopital's rule 2 times in this case. After one application, we were still at an indeterminate form, 0 over 0. So applying L'Hopital's rule once again then got us a real value result, 1/2. And so we will stop here and conclude that this limit does exist and equals 1/2.